But yes, as I stated already, we're going to be talking about the objects within our solar system. We're going to go ahead and start off with, of course, the bigger objects within our solar system, which are the planets. But I will do so as soon as I can actually get the chat to pop out. There we go. This makes things a lot easier on me. Typically, when Joe's here, he can help me out with the chat, but I'm gonna try to do everything by myself for today's stream. All right. So, of course, at the current moment, there are 8 planets. And so we're going to start off with the very first inner 4 planets of our solar system, which all pretty much share one thing in common. That is, they have rocky surfaces. These planets being Mercury, Venus, Earth, and Mars. So, to kind of walk through each planet, Mercury being the innermost planet of our solar system, closest to the sun, that is. Um, I believe this particular, well, as of right now, Mercury has never had any sort of visits, at least from any sort of robotics from Earth, to actually be on its physical surface, of course. But we have been able to take images of Mercury using using the messenger mission. There was 2 missions actually, but the messenger mission was one of them. Um, if we move on from Mercury, we can go on and start talking a little bit more about Venus. Now, the interesting thing about Venus is that of all the planets within our solar system, it's one, the hottest planet within our solar system, and two, we actually have been able to, besides Mars, we actually have been able to land things on Venus, and and do some scientific studies with that information that was obtained. From my understanding, this particular information, the data that we currently have on Venus, dates back as far as the 1970s, with some of the landers that I believe the Russians had sent to Venus to be able to acquire some data. I just missed something really big a few seconds ago. But the key things that I want to mention, of course, is that Mercury and Venus are our 2 innermost planets. Um, Venus is the hottest planet. Its physical size is similar to that of Earth's. Mercury is smaller. But the key thing was that it's the hottest planet, even though it's not the closest planet, which is actually very interesting. More than likely due to its atmospheric composition, which is the reason why it's probably the hottest. Moving on from Venus, we have the next rocky body within our solar system, which is Earth. I'm not going to go into too much great detail about Earth, except stating the fact that we did have a discussion about Earth a few streams ago. And lastly, I'm going to go ahead and move on to talk about Mars. Now, with Mars, which is actually which is the fourth closest body to the sun, we actually do have a lot more information on Mars. We've been able to, of course, send rovers to Mars to be able to study the the interior compositions of Mars, as well as understand its atmospheric composition and stuff like that. Um, Even currently, we have the MRO, the Mars Reconnaissance Orbiter, currently orbiting Mars, actively taking images of the Martian surface. Key things that I simply want to state about all of these particular planets of our solar system are that Mars has a very thin atmosphere. Um, Mercury has no atmosphere, and Venus also has an atmosphere, but its atmospheric composition is such that it's heavily opaque to as far as visible light's concerned. trying to think of all the things I can think about with these particular bodies. I think I've covered for the most part some of the key things I wanted to state. Let's see. But yes, these are the innermost bodies of our solar system. They're rocky, one, and they're much smaller in size compared to the planets in our outer portions of our solar system. But before we can even get to those, though, of course, in this situation, we're kind of moving from the sun out. Just past Mars, we run into these objects, which in white, which is known as the main asteroid belt. There was some cool atmosphere. So I'm quickly looking at the chat here, and Susie states there was some cool Venus atmosphere stuff in the Expanse at the end of second season. Yeah, I was reading and reading up on Venus because honestly, not too long before this stream, I knew very little about um, the composition of Venus, and apparently, I mean, we can send things. we can send things to the surface of Venus, but once there, it won't survive very long, and primarily because of the conditions on the surface of Venus. Apparently, it's very very harsh, and so quickly looking at another comment here. It says zero talks about Venus's upper atmosphere. Acid, I don't think it's going to work out too well for humans being able to survive in a region like that, right? But yes, welcome, VidBoy. Space, that's right. As Star Trek states, the final frontier. But yeah, we've now moved on from the inner four planets of our solar system to the next main object within our solar system, which is the asteroid belt or the main asteroid belt. Here depicted in white. The key thing that one should note is that the asteroid belt roughly rests somewhere between, I think it's about 2 AU to roughly about 3 AU relative to the sun. Where an AU, for anyone who doesn't know, an AU is. So, what do you think of the other black science man? I believe you might be talking about Neil deGrasse Tyson. Dr. Neil deGrasse Tyson. He's great. I love him. Um, I love his material. So I've been able to catch up with some of his what are they called, the debates, the Isaac Asimov debates. So I haven't been able to catch the most recent one back. I believe it was back in February, but I'm gonna get a chance to watch it. So, right, talking about the main asteroid belt. So it's composed of a lot of asteroids. Basically, asteroids are smaller rocky bodies within our solar system that are composed mainly of rock. So versus some other type of material, which I'll get back to in a minute with other objects in our solar system. But the white dots within this image correspond to the bodies within the main asteroid belt. And if I'm not mistaken, the physical mass of the asteroid belt, the masses contained within the asteroid belt, is probably somewhere close to I think it's like a few percent of our moon. Maybe like somewhere between like 3 to like 5% of our moon, somewhere like that. But as you can see, we have the main asteroid belt in white, but then we can move beyond that Am I giving a course in astrology? No. No, no, no. Well, no, Lagrange points are supposed to be Lagrange points are supposed to be points if I'm not mistaken where the force on that point is the sum of forces on that point is zero. Thank you, Susie. Yes, astrology no, astronomy yes. So I suck at giving good definitions for astrology. Um but astronomy is is the process of understanding the universe around us in a more quantitative manner. Astrology, um, I don't want to offend anyone, but I don't know. I'm gonna leave it up to chat to give a good definition for what astrology is. Um, am I talking about constellations that are part of? No, I am. Oh, you're axing. Okay, you're axing Bid Boy. Okay. Yeah, we're not talking any at the moment. We're not talking about constellations of any type. We're staying here home within our solar system. Thank you, Susie. That's actually a much better way of putting of describing what astrology is. Um, but Lagrange. If you're talking about Lagrange points, I've never ever. I've honestly never thought about them in terms of other planets. But if I'm remembering correctly, the Lagrange points for Earth, I believe there's like five of them. I think there's like five of them. But the Lagrange points are basically points in space where the sum of forces on the object would be zero. As far as the objects here within the plot that I'm currently showing for these particular bodies of objects, the Trojans and the Greeks, which honestly I know very little about. That's my caveat right there. But would they correspond to Lagrange points? That's a great question. I honestly don't know. I would have to look it up. I would have to look it up to be very honest. Yeah, Hanny, I'm sorry. I don't know. I can look it up really quickly and find out. But I'm not too sure. No, a Lagrange point is not like a Lagrange multiplier. Did I get something wrong here? So Paranor states that Goldilocks zones wouldn't be Lagrange points. I'm gonna take a quick moment to just quickly. And again, guys, this is kind of like a laid back conversation between you and I. Typically, it would be a laid back conversation between you, I, and Joe, but Joe couldn't make it today, so let's see what's going on here. Um, I don't think anyone brought up anything about Goldilocks zones earlier, Paranor. Yeah, I think we were talking just about Lagrange, right? Lagrange points. All right. Well, let's go ahead and move on, though. Beyond our main asteroid belt, which is also seen here in this image, would be one of the planets, in this case Jupiter. But beyond that, we run into what's known as the giant planets of our solar system. There are four of them. Two of them, the nearest two to the sun, Jupiter and Saturn, would correspond to being what's known as gas giants. Whereas as you move on beyond the orbit of Jupiter into the next two and very last planets of our solar system, Uranus and Neptune, you run into the ice giants of the solar system. Now, their naming for Jupiter and Saturn, that is, being the gas giants, is because of their composition. So the composition of Jupiter and Saturn, if I'm remembering correctly, is roughly around I believe it's like 90% hydrogen. But mainly its composition is composed of hydrogen and helium. Whereas with the ice giants, their composition is actually much lower in percentage as far as hydrogen and helium is concerned, and have higher concentrations of heavier metals or heavier elements. Hence the term ice giant. Um, Ice giant indicating that its composition is such that it has a higher concentration of of elements heavier than hydrogen and helium. Um, yeah, but key things to note here would be that, of course, Saturn has um, its ring system. Um, and as you can probably tell, I am not a major knowledge buff when it comes to these to planets, though. But and of course, depicted here in these images for Jupiter and Neptune, we kind of see like these two or these big circles, which will correspond to storms occurring on the surface so of these planets, or at least on Jupiter. Um, I know that the big red spot corresponds to a storm. However, on Neptune, there seems to be like a big blue spot there, but I can't say for certain whether or not it's a storm or not. But again, guys, this is a conversation, so feel free to add whatever information that you do know about the topic. Well, the thing about it is that the chemical composition of, let me put it this way. So everything within our solar system was originates from the same molecular cloud of gas and dust. However, due to how these particular objects formed, they were able to generate, well, different types of, I'm sorry, I'm stopping for a second to think about what I'm saying here. Um, hmm. Hanny has actually asked a question that's kind of got me stumped here. So to quickly remind everyone that what Hanny's question was, Hanny asks, why would the chemicals be more complex further out in the solar system? Um, The material that was used to produce the planets was the same, but the only reason why the chemical compositions would be different. And I don't want to say the only reason why, but one reason why the chemical compositions would be different is based off of how the planets were formed. Um, but as far as their actual formation, I don't have a great deal of knowledge on that. But nevertheless, it's a good question. It's one that I'm actually very interested in now, and we'll find out. So I don't know much about space, but can we talk about computer science? See, if Joe were here, that would be his major field there to be able to answer questions about. So I'm reading the very last comment here, and that's actually the next particular topic that we were going to move on to. Given that it was brought up, oh no, wait, we're not going to make it there just quite yet. Zero. So Zero did bring up the Kuiper Belt. We're gonna move. We're gonna get to that eventually, but before getting there, and again, we're kind of just moving slowly out from the sun to the outer portions of our solar system. The next object would be Pluto, the once former planet Pluto, now dwarf planet, is depicted here in an image taken by. I'm trying to think what image where did I acquire this image from? I know that for the previous images, the image of Saturn here was taken by the Cassini mission. I believe Jupiter was taken by maybe Hubble. The image I have here of Jupiter, and then the very last two images I have of Uranus and Neptune were taken by the Voyager two mission. But the image here of Pluto, I'm gonna assume that it was also an image taken by Voyager as well. But Pluto, which was demoted from status of full planet to dwarf planet not too long ago, is an object within our solar system, which apparently was the very first object discovered that's a part of the Kuiper Belt. Beyond the fact that it's been demoted from status of planet to dwarf planet, and that it's that at one time it was the outermost planet of our solar system, I don't have really much more to say about it. So we're gonna move on to the very next, and again I'm gonna keep up with comments here. How much water is there on Neptune? Dragon Nation states, I do not know. Um, but given that it's an ice giant, um, it would have a higher abundance of elements heavier than helium. For example, carbon, nitrogen, oxygen, sulfur. Let's see. But yeah, so moving on to this particular object that's on the screen currently, I'm showing an image of a comet. Specifically, this is the comet Ison. And the key things about comets are that they appear to produce their own light, but they're not really generating their own light. So a comet is an object that's primarily composed of actually it's two things, but I know one of them is ice. In the process of moving nearby the sun, what happens to the comet is that it begins to heat up, and this heating up of the comet produces a coma, and at times produces a tail. And it's the interaction between the comet's nucleus and solar radiation and particles that actually produce the light that we see from the comet itself. And then lastly, I wanted to talk about, and as you can tell, this is going to be a very short um, Astro 101, is the Kuiper Belt objects, which was brought up earlier. So water has been found on Neptune, but would it be in the liquid form though? I don't think it's going to be in. It's gonna if water was found, it probably wouldn't be in liquid form. But then again, I could be wrong. It's in ice. It's in the form of ice, solid. Only reason why I bring up only reason why I bring up the fact of whether the water is in liquid form or in ice form is because for life to be able to be supported by with on some planetary object, um, water would be required, and it would need to be in liquid form. But so moving on to the very last thing I wanted to discuss with our solar system would be the Kuiper Belt. So, and this is an image I pulled from off of Wikipedia, where the Kuiper Belt objects are the objects that are colored in blue. As we can see, they kind of sit roughly out at what appears to be somewhere around a radius of 30 to 40 ish AU. So the x and y axes are in units of AU. And noted within this image would be a depiction of the sun in the center, the four giant planets of our solar outer this our outer solar system, excuse me, Jupiter, Uranus, Saturn, and Neptune, and then finally we kind of run into the Kuiper Belt objects. These particular objects, from my understanding, are composed of asteroids as well as other types of bodies that are composed of ice. So, and again, guys, I'm not a big buff on this stuff. Um, I just wanted to come and have a good conversation with you guys about it. It's a good one, Peter. Not at the moment. But yeah, I think and there's actually also objects farther beyond the Kuiper Belt. Um, I remember at one point in time, sitting in on a talk, someone was talking about the Oort cloud, which if you guys start asking me questions about that, I really can't say anything about that. But um, yeah, that's also a part of our solar system, but it's much farther out. But yeah, kind of in a nutshell, though, these are the objects that are within the gravitational bounds of our solar system. And so we can now just kind of, I'm just going to go back to the initial image here, and we can kind of just generally talk about this stuff. I will try my best to answer questions. I can't promise anything. Because again, this is not my particular area of expertise. And the funny thing about it, like, I'm pretty sure you guys probably know a whole lot more about this stuff. Collectively, would know a whole lot more about this stuff. Um, but yeah, just looking at this particular image, of course, I know that there was a few things that I may have left out. For example, some of the natural satellites that surround the um, uh, the planets in our solar system. Our natural satellite being the moon. Then I know there's some other natural satellites around, for example, like Saturn, Jupiter. I don't think they're depicted here in this particular image. But yeah, this image kind of shows in general like all the major objects within our solar system. One thing I did find interesting is that the dwarf planet series actually is it actually its mass takes up a large percentage of the mass that it's actually stored within the asteroid belt. And another very interesting thing that I found out was that the planet Pluto actually has, I believe, 5 moons. Dragonation. Yes, I completely understand that. I know more about high energy particle um, physics than this stuff right now. But I believe there was a question that was let's see. Hanny's asks, why is the Kuiper Belt a belt, but the Oort cloud is supposed to be a cloud? Um, it might be more so due to the shape of these two particular objects. With the belt, it kind of forms probably like a ring around our solar system, whereas the Oort cloud is probably more spherical in shape. Now, this is my own personal thoughts on it, just based off of the wording. Again, guys, I know very little about the Oort cloud. I just know it was brought up in a talk at one point. I overheard it. So yeah, okay. So Vesta. So Noel brings up. Did you know that Vesta is bigger than? So if I'm remembering correctly, Vesta is it's one of the large asteroids within the asteroid belt, or probably it's probably actually not even considered an asteroid, maybe like a minor planet. Whereas I'm gonna so mess that name up. On Enceladus. I believe that's a moon of one of the planets, probably a moon of Jupiter, maybe. So Hanny asks, how is it possible that Pluto can have so many moons? Um, well, I would think that that would have to do a lot with its sphere of gravitational influence. So the thing about it is that so Vesta is not a dwarf planet. All right. So Vesta is just a very large asteroid in the asteroid belt. You know what? The interesting thing about it is that I generally know how a planet's defined, but I don't generally know how a dwarf planet's defined. Is it just so much that with dwarf planets they haven't cleared out all the material in their orbit? So Hanny states hydrogen, helium, and oxygen are the three most abundant elements in the universe. So I'm definitely with you on hydrogen and helium, but I did not know that oxygen would be the third most abundant element in the universe. Yeah, Susie. So I know I think I know the rules. I think one of them is, of course, a planet has to be able to clear out its path. There is also, I believe, a condition. Well, it can't be a moon. Of course, the planet can't be a moon of another planet. Um, then there might also be like two more rules for that, for it to be a planet. Wait, Vesta lacks hydrostatic equilibrium. Okay, so thanks, Hanny. So apparently, oxygen is the third most abundant chemical in the universe, and then carbon. Okay. But is the atmosphere required for a planet? I thought that Mercury doesn't have an atmosphere. Wait, I think another rule is that the planet has to have enough mass that it's spherical. So yeah, Noel brings up a very good point there. Wait, is that no as in you agree with me or no that you disagree? It doesn't have to have a atmosphere, right? Mercury had. So I thought that Mercury does not have an atmosphere. Okay, DPI, atmosphere is not a requirement. I thought that wasn't the situation that it's required. Yes, Larry, you definitely proved it with those numbers. That is definitely not spherical. I don't. You know what? I'm gonna look this up now. I'm interested because I thought that I learned long ago that that for the inner planets, of course, Earth has an atmosphere. Venus has an atmosphere that I actually just recently learned. But Mars has a thin atmosphere, and Mercury has no atmosphere. But let me see. I could look at that up and make sure that's correct. Ah, nope. Mercury, according to something I'm reading here, says that Mercury has a thin atmosphere. Oh, Mercury has almost no atmosphere. So it has an atmosphere, but it's just very, very thin. Okay. Oh man, you can call that an atmosphere, but good luck breathing. So yeah, I mean, I don't think we're gonna land on Mercury anytime soon. Yeah, I would have to agree with you, Thomas. The orbital dynamics of Mercury are kind of insane. I mean, just from what I can remember, I think we sent the messenger spacecraft to Mercury to take images, and eventually it crashed. I think after like a 4 year mission or something like that. Wow, that is insane. So Noel's statement here about the fact that the exhaust from the rocket from the Apollo program, the rockets from the Apollo program now actually compose a significant fraction of the moon's atmosphere. That's insane. When I see Joe, I'm gonna let him know that he missed out on a very good like discussion here. But yeah, my plan for the next stream though, guys, I'm gonna let you guys in on this. I want to talk more so about the dynamics of things within our solar system. That I feel a little more confident about. That is like how planets move and stuff like that. So so you want to give the moon an atmosphere of rocket exhaust. Um so me and Joe, we do the Astro 101 discussions every Wednesday and Friday after Daily Space. Oh Peter. Oh man. Oh, I'm about to start. That was a good one. So Hanny stated something here. I'm gonna allow it. I once heard if you put an atmosphere on the moon or Mars, it would take quite a while. Okay, on human time scales for it to dissipate. That might be a very fun, problem to try to solve. using diffusion and stuff like that. Well, guys, thank you guys for coming. This was actually a great Astro 101 discussion. You guys really made this like discussion great. So, and again, like I said, I'm gonna tell Joe what he missed out on. All right, guys. Well, I will be back. Well, Joe and I should be back on Friday after Daily Space. So, we look forward to talking to you guys then. All right, guys. Bye.